Hello, this is John Greiner with Basin Safety Consulting and Training. It's February 2021 if you haven't noticed outside, and it's definitely coming at us hard and cold. Make sure you have a good winter survival kit in your vehicle just in case you get stuck somewhere or stranded. If you need one, you can look on our website or give us a call, and we'd love to hook you up. Today we're going to be covering confined space safety, fall protection, and ladders and stairways. This covers 1910-146 permit required confined spaces and a couple other OSHA regulations for both fall protection and for ladders and stairways. So our goals with confined spaces are to obviously describe a confined space, understand the requirements of the OSHA regulation, and describe the entry requirements for permit required confined spaces. So first and foremost, confined spaces are deadly. There's no question about it. If you do a cursory review of the OSHA, it used to be called the Weekly Fatality Report, but now I think it's just called the Fatality Report online, you'll see that there are quite a few issues with confined spaces. In recent times, though, just to get you updated on the statistics, a lot of fatalities are happening from falling and being struck by or caught in between something. So another reason that we're going to be covering falls today as well. So in 2004 at a Tulsa wastewater treatment plant, a worker was killed when entered a confined space. There was hydrogen sulfide inside of it. Unfortunately, he did not do any monitoring before he went in, therefore didn't think he needed or have a respirator, didn't have any confined space training, or didn't follow a confined space training program. So all these things kind of work together against him. And ultimately, if you enter a confined space without atmospheric monitoring, the likelihood of getting sick or dying are extremely high. So a confined space, there's a few different definitions of a confined space. It's restricted entry and exit. So also limited is a word that we use. It's large enough for a human or a whole person to enter and is not designed to be continuously occupied, meaning you couldn't live in there. Can you go inside? Absolutely. So is a walk-in freezer a confined space? Yes, it'd be a confined space. Potentially, but the limited egress ingress, that's a full-size door, so can you get in and out easily? Yeah, you can get in and out pretty easily. You just walk in, walk out. So typically consider that a permit required confined space, although by some definitions you would consider it a confined space. In fact, some people would even consider the cab of a semi a confined space. So it can get a little bit deep depending on how you stretch those terms. But we're going to be focusing a little bit more on permit required confined spaces. So when a permit needs to be issued by the oil and gas operator, the company man, supervisor, etc. So typically that's going to happen when a space meets those previous criteria and has any one of the following: an atmospheric hazard, real or potential, the potential for entrapment or engulfment, and this can be by fluid, sand, potentially grain, really anything that's going to engulf a person. It has a hazardous configuration, so where getting somebody out easily would be difficult. If they fell down and hurt themselves or had a heart attack or something, could you get them out quickly and easily? And if the answer to that's no, then we're definitely going to want to issue a permit for that space. And lastly, it contains any other serious safety or health hazard. So this could be lots of noise, slippery surfaces, low lighting, electrical hazards in the space, a lot of different things, once again, that would increase the likelihood that somebody would get hurt inside of that space. So obviously we want to deal with those hazards prior to entry. And the first thing in any confined space, regardless, it could be a trench, it could be inside of a tank, treater, whatever. If you are a person who has to enter one of these spaces, is you need to test the atmosphere. So flammable gases, vapors, mists. The first thing we want to test for is flammability, making sure that we know that there is no gas that could ignite, because regardless of what you do, if you have a mask, an SCBA, a breathing air system, if you're gonna if it's gonna ignite when you're in there by sparking a tool or dropping a penny on the floor, God forbid, you would definitely want to make sure that you've taken care of that problem. So the lower flammability limit, it could also be dust. The second thing we want to test for is oxygen. Then we want to test for any toxic substances such as H2S, etc., to make sure that there isn't a hazardous gas that can overcome us and take our life. So typically out here in the oil field, we're dealing with H2S is one thing that's common. We're dealing with benzene is another thing that can make you sick or potentially kill you. Low oxygen inside of tanks is another issue. So really any sort of gas that depletes the oxygen. And inside of a tank, it's not designed, once again, for occupancy. So there's going to be other gases in there taking up space. So there's another scenario here at the Valero refinery out east. And essentially what happened at this Valero refinery, it was a space filled with nitrogen. And this was a reactor chamber at a crude oil refinery. There was a duct tape roll that had been dropped inside the space. There were three guys on the floor there. They were hoping to get the duct tape out so a crane could come in and put the elbow on top of this flange here. So essentially, gentleman falls in or tries to climb in to grab the duct tape, is overcome by nitrogen. The next guy goes in to try to rescue him. He goes down, and finally the third guy called. They didn't know nitrogen was in the space. They filled out a permit, actually, but they didn't test the atmosphere first. So they said no nitrogen in the space. Basically, nothing was in there, so we're good to go. But they were wrong, and ultimately two died from lack of oxygen. So engulfment, as I mentioned before, it's really just being completely covered by something. So grain silos, storage tanks, sewer, water main work, really being inside anything that can be filled with a fluid or granular substance that would overcome a person. So hazardous configuration, obviously inside of a turbine would be a hazardous configuration. And really, if you've ever seen these, they're extremely long. They have to actually go inside these blades here for different things. And we did a course this year, kind of training people to get in and out of those. And between the hub and the blade, it's actually a very small, manhole, if you will. So if someone's at the end of that blade there and needs to get out, it's going to be a nightmare trying to get them out. And then plus, obviously, you got to get them down 100 feet or so. So that would definitely meet the criteria of a hazardous configuration. But really anything where a lifeline wouldn't pull them out. So think of inside of an oil tank or a saltwater tank. It's not just a flat, smooth surface in there, right? You've got piping. Typically, you've got a 90 coming up from the bottom, and then you have your lateral pipe going out to the inlet. So if someone falls in there, there's going to be a big pipe in the way in preventing them from coming out. So asphyxiation is possible in there. Obviously, lack of oxygen is another issue, etc. So any other serious hazard, I mentioned that earlier, and really, sound, lighting problems, noise, slippery surfaces, a lot of different things would put us into the other serious hazards. So as you can see, a permit required confined space can happen very easily because there can be things in there. So the first thing we want to do is get rid of any of that before we enter the space. Can we cut the sound off? Can we improve the lighting? Can we clear the atmosphere? And in those cases, it is possible to change the nature or change the definition of the space from a permit required to a non-permit required. But a lot of times operators just say, hey, you know what? Good idea to fill out a permit, have all the extra help rescue if something goes down. So the posting of permit required confined spaces, essentially they want a sign out front as you're entering in saying, hey, this is a permit required confined space. Now, this is especially important at permanent facilities where that space exists. Typically for someone to get in an oil tank it's not as easy as just opening a hatch and, going in. You'd have to seriously want to go in, take off a lot of bolts, probably soak yourself and the surrounding area with oil. So it's not, like say you can just open a latch, but in other areas where these spaces are just part of, the daily work, they're not filled with something that becomes extremely important. And so, as I mentioned, reclassifying confined spaces can happen. OSHA does allow for that if you can remove the hazard. without entering the space. So an entry permit written program is essentially a part of your health and safety manual. That's just telling you, hey, there's a need for all these criteria to be met before we enter a space. We need to have a rescue crew there. We need to have an attendant. The entrant needs to be trained. The supervisor needs to be trained. Everyone needs to understand what's going on. So all that needs to be a part of your company's safety program before you enter a permit required confined space. So there's other things that we can do to enter a confined space without a permit. Once again, if enough ventilation is in there, if it's the right type of ventilation, if it moves enough air, there's actually a calculation of volume of air in the space, and then volume of air that the air mover's pushing or the fan's pushing, and if it's changing enough times per hour, then that would meet the criteria. But once again, typically we're not going through all those different types of steps to prevent a permit. Usually out here, 99 out of 100 times, we're just going to complete the permit just to make sure all criteria are met before we enter. So permits, getting a little of those, it's basically like a JSA, but it's specifically designed for confined spaces. So, obviously it's going to ask, why are you going in? Where are you going in? How long are you going to be in there? Who can go in? Who's watching the space? What's in the space that could hurt you? What are we going to do to prevent those things from hurting us? We blocked this valve. We locked it out. Obviously the signature of the supervisor is very important to be on there. What we're going to do before we enter to make sure that we're not going to enter if these things aren't true. Atmospheric test results are going to be on there. Rescue services, who is the rescue service? How are they going to get there? Can they get there within 15 minutes? How we're going to talk when the person's in the space, a walkie-talkie, a hand signal, whatever. What equipment we need to enter. Are there other permits? Is there a hot work permit we're going to need to complete as well, etc. So that's pretty much, once again, a more thorough JSA with very specific details about the confined space. So the supervisor for a confined space, his job is essentially to oversee the whole process. Without his signature and verification, you cannot go in that space. It doesn't matter if the company man says, you know what, go ahead, you guys are good to go. No, if the supervisor of the confined space job, now it may be the same guy, so in that case, that'd be okay, but essentially the supervisor of the confined space job has to sign off and say that it's ready to go. So he verifies the permit. He's familiar with the hazards and the procedures of the space. He authorizes the entry, oversees it, verifies rescue, make sure rescue services are there, make sure that other people don't come in, and that's also the attendant's job. Ends the entry revolution and can serve as an attendant as well. So with that, essentially what that means is that, if it's a non-entry rescue, you don't have to have a supervisor, an attendant, and an entrant. You can have the supervisor, be the attendant. But ultimately, with his signature on this, he's taking a lot of liability on himself for this job. So if those requirements aren't met, if he falsifies information, if there's not rescue services available within 15 minutes, etc., and something goes down, that individual, there's only a few areas that OSHA really will hold an individual liable, and this is one of them, permit required confined spaces. So really, if you are in this position, know that there are a lot of requirements that are on your doorstep with this type of work. So the attendant, is what it sounds like. His job is to attend the outside of the space. He's paying attention to the person inside, making sure that they're communicating, effectively, that they're not passing out or, hurt in any way. They're familiar with the hazards and the procedures of the job. So you can't be like, hey, we got a confined space job today to the guy pumping your gas at the Cenex and say, you want to come out and be the attendant? We need a guy to just stand there. That is not this job. They need to be very familiarized with the type of work and what can go wrong inside the space. So they keep track who's going in and out, stays outside the entry point at all times. Now, he can perform non-entry rescue. So he can have a hold of the lifeline or whatever and pull the guy out. That's perfectly acceptable. But ultimately, he cannot enter that space for any reason, even if the guy's hurt. That's the rescue person's job. He can't do that. His job is to monitor the outside of the space. Because, what if he goes in to rescue him? There's gases or something. Billy walks by and just enter. Now, I don't know why anyone would just enter a random hole or confined space without reason. But, once again, people are always surprising me. So, entrant, his job is obviously probably not the most exciting of the three. He's the guy doing the work inside. So he's going to have to know the hazards of the work, knows the safety equipment and other tools he needs to use, communicates with the attendant consistently, lets the attendant know if something's going on, and if a new hazard arises that they haven't discussed on the confined space entry permit or the JSA, he immediately leaves the space right now. He doesn't call and say, hey, what do I do here? This is happening. Like, his job is to recognize, hey, we did not talk about this. I need to get out. The reason for that is when a new hazard exists you didn't know about, typically you have no idea the extent of that hazard in an instant when it happens, right? So you're not like, hey, is this going to be bad? Is this not going to be bad? You radio out, hey, what do you guys think about this? If a surprise thing comes up, it's better to get out and then reassess and then enter in before you just stay in there and hope for the best, because things can happen extremely quickly inside of a confined space. So there are 3 options available for confined space rescue programs. As I mentioned, an outside third-party company, they typically have an air trailer. They might have the tripod, a stretcher, whatever you may need. They train your employees to provide rescue. That's the other option, is you can train your internal employees to provide rescue, which is perfectly fine as long as they're trained by a qualified outfit. They have to have first aid CPR, obviously. This is a long training, but it can be done. Or if non-entry rescue is possible, then good to go. We have a customer, they work in essentially freshwater cellars, and there's a valve at the bottom of it, and it's below the frost line, obviously. And that valve has to be reached by going deep inside the cellar. So they hook up a tripod at the top, drop him in. If he were to, go down, he's attached to a harness and a lanyard just like this with a winch, and they just winch him right out. So no one has to actually go inside the cellar with him to get him out. We can get him out by other means. In that case, we wouldn't need to have a confined space rescue service on standby. So non-entry rescue. Really, retrieval lines, spaces less than 5 feet deep aren't going to require rescue services, etc. Side entry is a difference. So the tailboard meeting basically is your JSA. Before you go in, this needs to happen. You can't just say, oh, the permit's good enough, because the permit's dealing with, it's going to ask you, what are the hazards? And you write them down. Low lighting, gas potentially, we have to wear it, SCBA, whatever. But it's not going to talk about how to mitigate those hazards or what you're doing to, prevent someone getting hurt. It doesn't do any of that. It's just write the basic hazards. And obviously in the tailboard meeting, the goal of that is to have everybody on the same page as how you're going to attack the work to keep everybody safe. So accessing the space. Any conditions that make it unsafe to remove an entry cover must be eliminated before the cover is removed, period. And we've already talked about that a little bit. But once that happens, we need to protect people from going inside, whether they could fall inside or they inside because they're just a strange person and they have a fascination with entering, manholes for whatever reason. Then, we need to protect them. So testing the atmosphere, as I mentioned, needs to be done. 4-gas monitor. If that 4-gas monitor gives us results that we don't like, we can provide the ventilation. As I mentioned, it has to be adequate. So here we have a ventilation, essentially hose going to the bottom of the tank and pushing the air out. That's called, forced air ventilation, or positive pressure. You can also pull the air out, but that one isn't as good. You're going to get pockets of stuff in there. It's just going to miss, certain of the chamber. So performing work in the space, the attendant needs to be listening to the entrant and hearing any problems that are going on. And they, it's not a bad idea to have code words, etc. Like, hey, this word, just pull me out, whatever it is. So he's monitoring, the attendant's monitoring anything that's space. Evacuating the space, once again, new hazard arises, you're out. Do not attempt an unplanned rescue. And 60% of people that die in confined spaces are unplanned rescuers. So people entering without training, without, a plan, and they're like, I got to go get my buddy, and they go in to get their buddy, and they don't make it because, when your adrenaline's pumping, you're breathing hard, for example, and if the issue inside the confined space is atmospheric, you're going to get a lot more of that into your lungs right away than even the guy who's in there working. So, once again, unplanned rescue, that's a no-no. Now, once you're done with the work, you complete the permit, you cancel it, and that permit needs to be stored for 1 year. My recommendation is do this on electronically on a tablet or something, so that way it's stored, forever. You don't have to track it down, where to go, who has it, did it stay in the truck, did it put on the way, leaving location. You don't have to worry about any of that. It's just covered. Contractors. So this is an important part of this. If, let's say, you have a confined space on your company's location, right? And you're like, you know what? We don't want to have to do any of this permit stuff. We don't want to have to train the guys and put them in there. I mean, I like Billy. I don't want Billy to have to go in that space. So we're going to hire out, Joe Schmo Roustabout, and they're going to come out here. And we're going to have them enter the tank. So we don't have to put our precious Billy in danger. That's fine. Absolutely, perfectly acceptable, and candidly, pretty normal. You want to hire people who are specialized in this type of work. However, this can't be a situation where you call someone, hey, can you do confined space work? And they, on the other end of the phone, kind of look around at their buddies and they're like, yeah, sure, we could do that. Yeah, okay. And have no idea what they're doing. Like if you hire a company, they actually have to be trained and qualified. If they come out there and they're just winging it, and basically just like, yeah, we can send Billy inside of a tank. Our Billy, we don't care about him. He doesn't make it. We're all good. We want his card collection. I don't know. Then Billy, Billy's put at risk, and you can't trade one Billy for the other, I guess. I mean, probably a terrible metaphor there, but you can't say, our contractors' lives don't matter, so we don't care if they have any programs. We don't care if they're doing anything. We're going to call them and just not even show up that day. And if someone dies or if they're not doing it right, not on us. Actually, it is on you, because this sort of space is, there's so many fatalities in confined spaces that there's like no wiggle room for like, oh, we didn't even check on them. We just figured they knew what they were doing because they said so. No, you need to oversee that work, make sure that they're doing it properly, etc. You can't just, put that on the contractor for doing the right thing. So this training, had your contractor company taken this training, it would not allow them to enter that space. This is an awareness training. Basically, here's the basic information about confined spaces. We're not going in deep. There's a 4-hour class. There's an 8-hour class. I think there's a 30-hour class. We don't teach the 30-hour class. That's I want to keep my employees around. No, I'm just kidding. But no, that's something you need a real certification for. So there are classes. We try to make them interesting, but this is just an awareness course. So once again, to reiterate, atmospheric hazard, potential for engulfment or entrapment, hazardous configurations, and any other serious safety hazard, make a permit required. Make a confined space permit required. The PRCS entry team has an entry supervisor, an attendant, and an entrant, and a rescue team, on standby if necessary, if non-entry isn't possible. All right, so there's confined space. Moving on, we have fall protection safety training, and then we'll get into ladders as well, kind of as a bolt onto this. So this is CFR 1926-501. You'll notice that this is not a general industry OSHA regulation, but a construction one. But they will refer to that in essentially if in oil and gas or any sort of other work, they'll take the data from it. So if we're working at heights. So falls are one of the leading causes of accidental deaths. In fact, as I said, you look at the OSHA fatality report, about every third fatality this year in the last 6 months, and there's probably 30, I think. No, excuse me, in the last quarter, 3 months. About 10 or 12 of those have been falls. So it's very common. Every other day, pretty much somebody's dying from a fall. So most of them can be prevented. A lot of times there's not guardrails. They're not tied off to something. And sometimes they're not even like far falls. I mean, I think there's one, if you look it up, and you can just Google it, OSHA Fatality Report 2021 or whatever. There was a guy who fell 3 feet, which is basically the height. It's shorter of a fall from you just tripping on something and falling on the ground, and he expired. So falling does happen and can be extremely hazardous. So as I mentioned, statistics: the majority of industries or accidents in our industry, 15% of all accidental deaths, more fatalities than any other cause but motor vehicles. And OSHA standards for walking and working surfaces apply to this, and basically when dealing with walking around. So, or walking and working surfaces are our fall protection requirements. So, housekeeping: workplaces must be kept clean, orderly, and sanitary. This prevents people from slipping. Floors should be maintained as clear and dry as possible. We don't want to have congested stuff, slippery surfaces, etc. And this can happen in the course of a job pretty quickly, right? We were dealing with a spud rig this week. When they're pulling casing or tripping out because something's stuck or plugged or whatever, there's going to be fluid everywhere on that floor. There's no way to prevent it. So in that case, they can't have it be clean and dry all the time. So they have to figure out other methods to prevent people from slipping and falling. So any deck or, platform above 4 feet, needs to have some sort of handrail. Needs to be able to withstand the outward push of 200 pounds is kind of the number. So a fall prevention system, like for example, this gentleman here, if he had a, something that he could anchor to with even just a short, tie-off belt or whatever, he would be fine. You can have a 2-foot lanyard or a 3-foot lanyard that prevents you from falling over the edge, rather than having something 18 or 20 feet up that you're connected to. So inspection, obviously prior every day before using it, it needs to be inspected. If it's not working, take it out of service. You can cut it up. You can do whatever you need to do with it, but ultimately needs to be inspected. And we're going to go into that a little bit more thorough here. So a body harness is obviously the part that goes around us. You want it to fit snug. It's going to hit the 5 major, it's typically called a 5-point harness. It's going to be around the 5 strongest parts of our body. So the thighs, pelvis, waist, chest, and shoulders. That's the strong part of our body, because this is going to absorb a lot of force if we actually do fall. And it can be extremely painful. So you definitely want that dispersed across the stronger parts of your body. So you definitely want it to be secure. If you notice the configuration of the lower straps around the thighs, if those aren't secure and something can kind of get in between that and your leg and you fall, it's going to be an extremely bad experience. So you definitely want to make sure it's snug and supposed to pull where it's supposed to pull to protect you. So there's also D-rings, and the placement of the D-rings changes depending on the type of work you're doing, right? Like you're obviously going to have one in the back. Sometimes you're going to want it higher. Sometimes you're going to want it lower, right between the shoulder blades. You have side D-rings, you have one in the front. It just depends on what type of work you're doing. So make sure if you have a harness, it's correct for the type of work you're doing. Really, connectors are any of the metal parts that, hook or loop or a ring. So they have to lock, and they're double acting. So you have to push in 2 places for them to open. Like I said, there's a lot of connectors on your system, so they should be able to move freely, right? They shouldn't be, tied or twisted or bent or anything. They need to be easily moved and inspected. So anchorage is really anything that you're connecting your harness to that's holding you when you fall. So it's a secure point of attachment for lifelines, lanyards, and deceleration devices. So 100% tie-off means, you'll hear this a lot in this world, it means that you're always connected to an anchor somewhere. So you may need to have two hooks, one that you hook and then you move, and then you hook the second, release the first, etc., which can be kind of cumbersome. In the near future, the fixed ladders on like pumping units and treaters that even have the cage on them, you'll need to have 100% tie-off even when working inside of those ladders. So determining proper anchorage points as far as height goes, essentially you need to take a few different things into consideration. 1, the height of worker. 2, the 6-foot length of lanyard. 3, the 3.5-foot deceleration distance. And lastly, the safety factor. So you put all these together, add them up, and that's how you get your anchorage point. A lot of times people forget the safety factor, but that's extremely important. So your lanyard is the length of strap that goes from your harness to your anchorage point. Typically it's 4 to 6 feet. It can be flexible. It may not be flexible. It may be fixed. Just depends on what type of work you're doing. An SRL can also be used as a lanyard, and typically they're called self-restraining lanyards or lifelines, and they prevent you from dropping if you fall. So they'll essentially catch you. Works a little bit like a seatbelt, where if it pulls hard, then it locks in place so that you don't fall any further. Obviously, the nice thing about that, and really the goal of fall protection, is fall prevention, keeping you from falling over the edge, keeping you from falling down the ladder, holding you tight and preventing that fall from actually happening. So anchor point requirements, just like every part of the fall protection system, need to be able to withstand 5,000 pounds. So each connector on your harness has a 5,000 pound pull rating on it. Now, once you've fallen in the harness, actually fallen, not like been held by the SRL, that harness needs to be removed from service, as well as the lanyard, because essentially they're designed to be pull tested once, or essentially acted on once, not more than once. So we want to make sure it can hold on 5,000 pounds, and that's kind of the main point of the anchor. So handrails, guardrails, not a 5,000 pound tie-off point. As I mentioned before, they are designed for some sort of impact, but it's 200 pounds outward pressure. So basically a 200 pound person can push against it. It's not going to break or bend on them. But as far as falling downward, they're not designed for 5. They may be, like certain barricades or handrails may be designed for that, depending on where you're at, but 9 times out of 10 they're not going to be. So storing harnesses and taking care of them, I recommend hanging them if you got a nice, dry, clean place. You can put them inside of a storage bin, such as the one in the photo here. But you want to make sure that they're mostly out of sunlight. That's the real killer of the material in harnesses, is sunlight. So the less sunlight, the better. But chemicals, oil, ink, you don't want to mark them, because that can degrade the webbing of the harness and lanyard as well. So kind of wrapping up fall protection. Obviously keeping your work area clean so that there's nothing to trip on is big. We're going to talk a little about ladders here in a minute. You want to check harnesses, make sure to inspect them, that there's nothing, there's not frays or holes, or sunlight hasn't beaten down and kind of degraded the quality and integrity of your harness. All the fall arrest components need to be free to move. They can't be rusted, etc. Check your anchor points, make sure they meet that 5,000 pound mark, which, if they're manufactured for this purpose, they will. And then obviously make sure that they're clean and stored properly. So moving into stairways and ladders. So, for the most part, man lifts are always going to be better than using a ladder. But if there's instances where we can't use them, we definitely want to make sure that our ladders meet the requirements of our needs. So the hazards, stairways and ladders may cause injuries and fatalities among workers. This is a photo I actually took myself. This individual was stepping between 2 ladders in order to hang that piece of fascia there. I think he was about 18, 20 feet up. His name was Noah. I actually met him after this photo and talked to him. He, was taking a risk here, and, definitely could have been in a lot worse condition. He did survive the situation, but it was a little bit of a mess. So slips, trips, and falls on stairways and ladders can happen. So by the end of this training, we want to make sure that we understand the requirements for stairways and ladders and the safe practices and requirements as well. So stairway or ladder, there must be a stairway or ladder at point of access where there's an elevation break of 19 inches or more. So that's pretty much our standard. Hey, is there a 19-inch break here? We need to have some sort of step or whatever. So loading docks, etc., need to have. So a handrail is obviously what we put our hand on when we walk up the staircase. The stair rail is actually preventing you from falling over the edge of it, right? So you probably have a handrail heading upstairs, but you probably also have a wall on both sides. Whereas typically in a lot of open areas, you're going to need that stair rail, such as at a tank battery. So the strength, as I mentioned, needs to have a 200-pound inward or outward rating, so it needs to be able to falling through it. Stair rails with 4 or more risers are what require that handrail. So this would be a no-no here. If it has 4 or more, you need a handrail. Have the stairs by themselves. Stairways with 4 or more risers or more than 30 inches high must have a stair rail along each unprotected side or edge. So that's a no-no there. And obviously during construction, you see this a lot. It's pretty normal, but ultimately, if that guy were to just, trip or slip, if it had just rained, he's going to have a very bad day. So dangerous conditions that exist out there, obviously slippery surfaces, etc. So one question I have is, what can we do about stairs, whether over the containment system or the dike, heading up to the tank battery when it's icy? Those are metal stairs. Depending on the type of stairs, and cleats aren't always the best option because they can cause more of a trip hazard. So what can we do? And really this kind of falls into the work practice side of things, walking slowly, taking small steps, not being in a hurry, not carrying heavy things if you can avoid it, etc., because all those things are going to throw off your balance. We want stairs free of materials or things that can cause us to fall. So now we're going to get into ladders a little bit. Portable ladders or A-frame ladders cannot be used as essentially, lateral ladders. So they're not designed for that purpose. If you inspect the ladder and there's a rung broken, it's twisted, especially with aluminum ladders, you get this a lot. They can get twisted if they're not properly cared for. The brace arms are broken or bent, and you just need to take that ladder out of service. And metal ladders, obviously, we do not want to use those near electrical equipment, or wood ladders. Actually, wood ladders can hold water and become a conductor, so you want to make sure you have carbon fiber if you're working near electrical equipment. So some do's for ladders. They must be kept in a safe condition. Once again, if you just throwing them around all the time, they're going to get bent and beat up and need to be taken out of service. Keep the area around the top and bottom of the ladder clear. Ensure rungs, cleats, and steps are level, uniformly spaced. Ensure rungs are spaced 10 to 14 inches apart, which, typically you buy these from a manufacturer, they're going to be fine. And keep ladders free from slipping hazards. Store it on the ladder at all. So, what we see here is, and you can actually use, there is something called a ladder platform that you can connect between 2 ladders to work across. This is not one of those. This is obviously homemade. But they need to be used for their intended purpose. Ladders can be tied together to make, ladders cannot be tied together. They have to be manufactured for their length. You don't want to use single rail ladders and then load ladders beyond the maximum load for which they were built. You don't want to use those that you're, meeting the right specifications. So ladders need to be secured to prevent accidental movement. So that can be, rebar anchor. You can use a cement block. You can use a lot of things to prevent it from slipping. And then on top too, you want to tie it off if you can. You want it on a nice level surface on the ground as well. So some ladders do extend, obviously, that's fine. And just make sure that the pins are in place. And then when it hits the point of intersection, it needs to extend at least 3 feet beyond the point of intersection. So that allows you to get off of the ladder safely onto the platform and then return to the ladder safely from the platform without having to reach down and kind of put your body in an awkward position. So you should be able to relatively easily get onto that ladder. So fixed ladder requirements, essentially They need to have obviously a ladder safety device. Nowadays, it is required to have an SRL. Well, it's not quite yet, but it will be. I think when the next, I think it's less than a year now, it's going to require you to have an SRL on these. Cage or well on multiple ladder sections. Each section should not exceed 50 feet for these bad boys. So near energizing or electrical equipment, it's a no-no. There's a reason our hard hats are designed to protect us from 20,000 volts, but I do not recommend testing them out in this way. If you come into contact with it should protect you, but definitely 10 feet is the minimum from electrical equipment. Definitely. So top steps are a no-no. They're really not steps. I don't even know why they should really have them rounded or something so no one steps up there. But they're not designed to be stepped on. It essentially makes the ladder extremely top heavy, and you're not really being supported by either side directly. So it's trying to support your weight on two sides of the ladder, which actually removes the integrity of support. So that's why that top step's not a damaged or defective ladders, as I mentioned, a missing rung, a bent side rail, etc. Need to get it out of service. You can mark it do not use. I recommend just immediately put it in the trash. Recommendation. So when climbing the ladder, you definitely want to have 3 points of contact at all times, going up or down the stairs, or up and down the rungs. And you cannot carry anything in your hands. To truly, have 3 points of contact, you can't be carrying anything. Tool belts are a good idea. You can get up there, attach some sort of cable system to lift up your tools or buckets or whatever, but you don't want to carry them up the ladder. So last thing I want to cover is when using a ladder, the bottom of the ladder needs to be essentially there's a 1 to 4 foot calculation. From the top of the point of intersection, you'll see in this photo where the ladder hits that beam. So from that point, if you were to measure straight down, if it was 20 feet, the bottom of that ladder, if you divide that by 4, the bottom of that ladder where it starts needs to be 5 feet out. So you take the height of the point of intersection, divide it by 4, and that's where the base of the ladder needs to be out from the wall or the vertical. So essentially at that point, 5 feet out is where you're going to want to secure that ladder, place it, and make sure the feet are in good condition and are actually gripping the floor surface well. Also not a bad idea if you can have another guy hold it or once again have securement. So that covers our confined space, fall protection, and ladders safety for this month. Go ahead and complete the test below. If you have any questions, let me know. There is a link above the video here for the actual PowerPoint. If you want to download that, you just click it. You can download it or review it as we go as well in case you missed something. So please have a nice, safe day out there, and we'll see you soon.